Hi everyone, welcome to Lecture 24 on Basic Inorganic Chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will study types of solution reactions, we will study formula equations, we will study ionic equations, we will study acid rain, formation of acid rain, and effects of acid rain. We start with types of solution reactions. There are three main types of reactions that occur in aqueous solutions. These are acid-base reactions, precipitation reactions, and redox reactions. We have already looked at acid-base reactions, which are simply reactions between acids and bases to form salt and water only. So today we will look at precipitation reactions. We now look at precipitation reactions. A precipitation reaction occurs when you mix two solutions and an insoluble solid separates out of solution and settles at the bottom. If you have a look here, two solutions have been mixed and an insoluble solid has separated out of solution and settled at the bottom. This solid that settled at the bottom is called precipitate, and this is an example of a precipitation reaction. This is an example of a reaction that forms a clear solution. So precipitation reaction occurs when you mix two solutions and an insoluble solid separates out of solution and settles at the bottom. We now look at uses of precipitation reactions in analysis. Precipitation reactions are used in chloride analysis and in agentimetric titration. In chloride analysis, precipitation signifies the end point during titration. So when you are doing chloride analysis, formation of insoluble silver chloride signifies the endpoint during titration. In agentimetric titration, precipitation is used to determine the chloride content. So the endpoint of the titration is reached when you form red precipitates of silver chromate. So precipitation reactions are used in chloride analysis and in agentimetric titration. Now we look at how to describe reactions in solution. Equations are used to describe what happens during a chemical reaction. Whenever we carry out any experiment in the laboratory, we use chemical equations to describe what has happened. The types of equations used are formula equation or ionic equation. A formula equation shows how reactants react to give products. For example, here, these are the reactants, and this is an example of formula equation. It shows us that HCl reacts with sodium hydroxide to give sodium chloride plus water. It shows us how these reactants rearrange to form new products. Formula equation also gives us the number of moles of reactants and products. For instance, in this equation, it shows us that 2 moles of H2 reacts with 1 mole of O2 to form 2 moles of water. Formula equation also shows us the state of the reactants and products. For instance, here it shows us that this reactant KCl is aqueous. It shows us that this product, silver chloride, is solid, and it shows us that this product, potassium nitrate, is aqueous. So a formula equation shows us how reactants react to give products. It shows us the number of moles of reactants and products, as we have seen here, and it shows us the state of the reactants and the products, as we have seen here. We now look at ionic equations. Ionic equation shows us how soluble molecules in solution that separate into positive and negative ions react in solution. The molecules must be soluble to separate into positive and negative ions. When molecules are insoluble, they cannot be broken apart. Solids cannot be separated into ions because they are not soluble in water. This is an example of an ionic equation. K plus and Cl minus both come from potassium chloride. Because potassium chloride is soluble in water, it separates into its positive and negative ions. Ag plus and NO3 minus are from silver nitrate. Silver nitrate is soluble in water, so it separates into its positive and negative ions. Silver chloride is solid. Because it is solid, it is insoluble in water, so it cannot separate into its positive and negative ions. Potassium nitrate is soluble in water. Because it is soluble, it separates into its positive K plus and negative ions. So, molecules must be soluble to separate into positive and negative ions. When molecules are insoluble, they cannot be broken apart. So any compound that is in solid state cannot be separated into ions. Okay, let's look at formula versus ionic equation. The reaction between sodium chloride and silver nitrate gives silver chloride plus sodium nitrate. This is an example of formula equation. The formula equation shows us how reactants rearrange to form new products. So, sodium chloride has reacted with silver nitrate to form silver chloride plus sodium nitrate. The formula equation also shows us the number of moles of each of the reactants and the number of moles of each of the products that are formed. So here, 1 mole of sodium chloride reacts with 1 mole of silver nitrate to give 1 mole of silver chloride plus 1 mole of sodium nitrate. This is the ionic equation for this reaction. So sodium chloride is soluble in water. Because it's soluble, it will break into its positive and negative ions. Silver nitrate is also soluble in water, so it will break into its positive and negative ions. Silver chloride is insoluble in water. Because it is solid, so it will not separate into its positive and negative ions. Sodium nitrate is soluble in water, so it will separate into its positive and negative ions. So these are examples of formula and ionic equations. We now look at how to write ionic equation when you are given formula equation. If you are given this formula equation and asked to write the ionic equation, you look at the state of each of the reactants and the products. Any compound that is aqueous will separate into positive and negative ions. But any compound that is solid, like iron 2 hydroxide, will not separate because it is insoluble in water. So KOH will separate into positive and negative ions. Iron 2 nitrate will separate into positive and negative ions. Iron 2 hydroxide will not separate because it is solid and insoluble. Potassium nitrate will separate because it is aqueous and soluble in water, so it will separate into positive and negative ions. So this is how to write ionic equation from formula equation. Any compound that is aqueous will separate, but any compound that is solid will not separate into its positive and negative ions. Today, we will learn about what causes acid rain. Okay, the pH of normal clean rain is between 5 and 5.5. This pH is slightly acidic. Remember, pH values like 1, 2, 3 are more acidic. The higher the number, the less acidic the solution is. However, when rain combines with SO2 or nitrogen oxide that are produced from power plants and automobiles, the rain becomes much more acidic. And typical acid rain has a pH value of 4, while normal clean rain has pH between 5 and 5.5, and this pH is only slightly acidic. So what causes acid rain? When CO2 in the air combines with atmospheric water, it forms carbonic acid according to this equation. So this is CO2 plus atmospheric water. It will form carbonic acid. So this carbonic acid releases H plus ion to rain and therefore increases its acidity. So this is your carbonic acid. When it ionizes, it will release H plus ion plus HCO3 minus ion. This H plus ion increases the acidity of rain. So this is what causes acid rain. We now look at sources of acid rain. Some of the sources of acid rain are emissions from power stations. They increase the acidity of rain. Emissions from oil refineries. Coal with high sulfur content. Emissions from car and truck. Bacteria decompositions. These are some of the sources of acid rain. Okay, we now look at formation of acid rain. When oxygen reacts with SO2, it forms SO3 according to this equation. SO2 plus O2 gives SO3. When SO3 reacts with atmospheric water, it forms sulfuric acid according to this equation. SO3 plus water gives H2SO4. This sulfuric acid releases hydrogen ions because it has 2 atoms of hydrogen, and these hydrogen ions increase the acidity of rain. When nitrogen oxide reacts with atmospheric water, it forms nitrous acid according to this equation. NO plus water gives nitrous acid. Again, this nitrous acid has hydrogen ion that it can release, which increases the acidity of rain. When nitrous acid reacts with atmospheric water, it forms nitric acid according to this equation. So again, this nitric acid has this hydrogen atom. So when nitric acid ionizes, it will release one H plus ion, and this H plus ion adds to rain and increases its acidity. So this is how acid rain is formed. We now look at the harmful effects of acid rain. One of the harmful effects of acid rain is that the toxic effect of aluminium leached from soil by acid rain decreases fish population in rivers. Another harmful effect of acid rain is that overspill of accumulated acid on the snow kills a lot of fish during spring. Another harmful effect of acid rain is that it dissolves waxy coatings that protect leaves of plants from bacterial infection. Another harmful effect of acid rain is that it dissolves minerals like magnesium, calcium, and potassium from the soil. Acid rain also corrodes metals, textiles, paper, and leather. So these are some of the harmful effects of acid rain. Right, so this is where I'm gonna end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture. Bye.